Hi guys, today we are going to talk about vapor pressure of liquids. So in the vapor pressure is the pressure that is exerted by vapor over a liquid. So what does that mean? Well, we know that pressure is caused by collisions of gas particles. So if you have a liquid, in that liquid, not all the particles are moving at the same speed. Some of these liquid particles are moving super fast, some are moving kind of slow, some are moving kind of average. The ones that are moving really, really fast, if they get close to the surface, they can actually escape and come out and stay at that surface as a gas. So right here, the fast-moving particles as liquid are going to escape and become gas, and there will be gas particles right here at the very surface of the liquid. And because those are gas particles, they are going to collide together, and that's going to cause pressure, and that's what we call vapor pressure. So if this was water, for example, some of these liquid water particles that are moving fast, they can escape, go at the surface as gaseous water particles, and those gaseous water particles would collide together and cause a vapor pressure. So let's talk about how vapor pressure relates to intermolecular forces. So if you have a substance that has very strong intermolecular forces, that means particles are so attracted to each other, they clump together, they want to be together. It's going to be much harder for that liquid, for the particles to escape and become a gas at the surface. And so less of those particles are going to escape, so you're going to have less gas particles and less vapor pressure. So strong intermolecular forces means that you have low vapor pressure. On the other hand, if you have a substance that has weak intermolecular forces, so particles are not really attracted to each other very much, it's pretty easy to separate those particles. It's easy for those fast-moving particles to escape and become a gas. So more of your particles are going to escape and be at the surface as a gas and collide together and cause high vapor pressure. So if you have low intermolecular forces or weak intermolecular forces, that's going to produce high vapor pressure. So the weaker the attractions, the more vapor pressure, because the more particles are going to escape and become gas. So this right here is called a vapor pressure curve. You look at the vapor pressure versus the temperature, and you'll see that you have different substances, but for all of these substances, you'll see that the vapor pressure increases with temperature. The reason for that is because if I increase my temperature, that means my particles are moving faster. And if the particles are moving faster, then more of them have enough speed to escape and get to the surface and become a gas and collide together and cause vapor pressure. So the higher the temperature, the higher the vapor pressure. And we can see that those all have positive slopes here. You can also, if you're looking at different substances, you can also tell the strength of the intermolecular forces from these curves. Because we know that the substances with stronger intermolecular forces are going to have weaker or lower vapor pressure. So let's pick a temperature here. Let's pick 300 Kelvin, for example. And you'll see that water has the lowest vapor pressure. That tells you that those particles are really attracted to each other. Less of them are escaping, becoming a gas. And so water has the strongest intermolecular forces out of these three. Versus ether, it has the highest vapor pressure at that temperature, which tells you that the particles are not very attracted to each other. It's easier for them to escape and become a gas at the surface and collide together and cause higher vapor pressure. So ether would have the weakest intermolecular forces out of these three. Water would have the strongest intermolecular forces out of these three. You can also, from this curve, be able to tell the boiling point of different things. Because boiling means that the vapor pressure is equal to the external pressure. So I love tea. I'm always drinking tea at home. I heat up my water, and as soon as I see bubbles, I don't say, oh, look, the water is boiling. I'm ready to, put my tea bag in there. Nope. I say, oh, look, the vapor pressure of the water is equal to the external pressure. It's time to put my tea bag in there. Again, boiling means the vapor pressure is equal to the external pressure. So normally, liquid water, for example, at room temperature does not boil because its vapor pressure is lower than the external pressure. So what do you have to do? You have to heat it up, increase its temperature, so then more particles are moving faster, more particles are able to escape and become a gas and collide together. So when the vapor pressure equals to the external pressure, that's when we say it boils. So if you look back at this, the vapor pressure is going to equal to the external pressure when it's boiling. So, let's say you're at, 400 millimeters of mercury, and I want to know what the boiling point of ether is. I look at 400 millimeters of mercury. I go to ether, and then I go down and say, oh, looks like it's about 290 degrees Celsius, or 290 Kelvin or so. So these are all boiling points along here because boiling occurs when the vapor pressure is equal to the external pressure. So when the particles throughout the liquid have enough kinetic energy to vaporize and equal to that external pressure, that's when a substance boils. Then, as you saw from the previous curve, boiling points are different depending on what the external pressure is, because if my external pressure is really high, then my boiling point goes high as well. If my external pressure is low, then I only heat it up just to match, so lower boiling point. The normal boiling point is the one where the external pressure is equal to 1 atm. So the external pressure is going to determine what your boiling point is, like we saw in the curves here. So back to here, this is 760 millimeters of mercury, or 1 atm. And so this is the normal boiling point of ether. Right here, this temperature would be the normal boiling point of ethanol. And right here, this would be the normal boiling point of water, which is 100 Celsius, 373 Kelvin. The temperature of a liquid can never rise above its boiling point. If you remember from our heating curves, when we reach a boiling point, we stay at that temperature until all the liquid particles have turned into a gas. And so you can't get a liquid to go past its boiling point. You also can't get a liquid to go below its freezing point, because if you're cooling it and you're at the freezing point, then all of the liquid will turn into solid before the temperature changes. So a liquid can only be in between its freezing point and its boiling point. So knowing that, we can actually change the boiling point. If you live on, at high altitudes, like in Denver or something like that, well, the external pressure is lower up there. And so what happens to the boiling point? The boiling point is actually lower than normal. So if you go up on a mountain and the external pressure is lower, then I only have to heat up my liquid just enough to match that. And so my boiling point is lower than it normally would be at normal pressure. So if you ever get these boxes of cake mixes or pasta or something like that, and it has the cooking directions, a lot of times it has high altitude cooking directions, because the lower external pressure means that you require a lower vapor pressure to match it to boil. And so your substance will boil at a lower temperature, which means that your food will actually cook slower. Because, instead of water boiling at 100 Celsius, well, maybe it boils at 90 Celsius only. And so it might be easier to get it to 90 Celsius, so it's easier to get it to boil, but it's going to stay at 90 Celsius. And so your noodles will be cooking at 90 Celsius instead of 100 Celsius. So it will take longer for your noodles to cook, or for your cake to cook. So if you are at high altitudes, you have to cook the food for a longer period of time because it's cooking at a lower temperature. So what if you want to cook food faster? What do? Well, you do the opposite. You increase the vapor pressure by using something like a pressure cooker, or you put a lid on your pot. That's basically how a pressure cooker works, except it's like tight, so no particles escape. So the pressure really, the external pressure really increases. So, if this was normally what the regular external pressure is, I'm increasing it even more. So I have to heat up my liquid to an even higher temperature to match that vapor pressure. And so my substance will boil at a higher temperature. But because it's boiling at a higher temperature, it can cook the food faster, because even though it's going to take longer to go to that higher temperature, but my food is cooking at a higher temperature, so it's going to take less time to cook. So if I'm cooking pasta again, instead of my water boiling at 100 Celsius, maybe I get it to boil at 110. So now my noodles are cooking at 110, so I don't need it to cook for as long of a period of time.